Any questions? Any questions from the previous one? I think it's might not. You were
No, teacher.
okay. You were able to. Okay. So if I go through with these ones, all these ones. Okay. Chapter. We completed up until the last point, right? The everything was
Yeah.
completed. Okay. Okay. Now we have the unit 2. Unit 2 means there we have functions. Functions also, I think few things we have already discussed, but anyway, we'll be working with the functions. So this part anyway, it won't, it's I can't say useless. Why do we study the functions? Because actually for the O levels also there we did some interpretations with the expressions for these functions related ones. So actually why we have to use and why we have to study these functions, that's for the temperature of a hot drink as it cools over time. And also these are kind of few examples. Anyway, we'll move to the theory part. So here,
Okay.
this is where the chapter starts. One is the definition of a function. So when it comes to definition of a function, function means a relation that uniquely associate members of one set with members of another set. For example, here we have, let's assume we have two sets of data. One set will be x and the other one would be y. Then what will happen? For each and every x term, for each and every x value, there should be a unique y value. So that means it would be either this way. Okay, it can be either this way. So let's assume like this. But
Yeah.
it won't be like this. See, now for this x value, we have two y values. No, it won't be like that. Anyway, if it's a function now, that relationship actually should state uniquely associates with members of one set to the other set. Because for each and every x value, there's a unique output value in y. That's what we called functions. So if I tell you with the graphs, so for the graphs you may have these type of ones, we can get as functions because there's per x value, per input value, we have only one y value. But what will happen if we have a graph like this? See, if we have a graph like this, then what will happen? For this particular x value, we have multiple y values. No, we have two y values. That
Yeah.
is not actually a function. This is not a function. I'm just explaining in brief. So now what
Okay.
Yes. So now what will happen? An alternative name for a function is a mapping. So we can use the word called mapping as well instead of this function. And also, when it comes to function, there are two types of function. One is one to one, the other one is many to one. Now let's see what we call this one-to-one function and many-to-one function means.
So we don't have a one to many function,
No,
right?
no, we don't have because if it's one to many now, it won't be a function. No. That's the case. Because if it's one to many, that means per one value in x, we should have many values in x. That means it's not a function.
Okay.
But for the one to one means it would be per input value. We have like only one unique output value. So if the mapping looks like this, then we can say it's as a one-to-one mapping. Many to one means For many x values, that means for many input values, we might have only one output value. See, like this, for both x1 and x2 input values, we have only one y output value, but so far still it's a unique one.
Yeah.
The unique one. It's not repeating. These ones are not mapping with the multiple output values. So one to one. For this kind of situations, we call them as one to one. For these kind of situations, we call them as many to one. So for both of these two coming under these functions, but if it's one to many none, it won't be a function. That's what here we have. So we learned about what is function, and we can give another name for this function as well with mapping. And then one to one and many to one. These two also we discussed. It's
Uh,
clear up to this point. Okay.
yeah.
Then if I erase this one and if I move further, now what we have, so here, look at this example. They have given the function of x, which I'll say it as y is equals to x plus 2. If we draw the graph like this, we already know how to draw the graphs, and this is a linear
Yeah.
line, a straight line. Then you can see per particular x value, we have only one unique y value there. So that means it's anyway a function. A
Yeah.
function, and also it's a one-to-one function as well. That is it. Then a one-to-one function has one output value for each input value. Equally important is the fact that for each output value appearing there is only one input value resulting in this output value as well. So we can write this function. We can write this function. How we gonna write this? So how we gonna denote this function of x? That is this x goes to x plus 2. Function of x, that is this x goes to x plus 2. This is the method how we gonna indicate or how we gonna denote this for x in real numbers. So this is like with the set theories, no? If
Yeah.
it's using directly the fx, I mean the function of x term, then we can rewrite it directly as fx is equals to x plus 2. That's how it is. So this is done. Is read the function f is such that x is mapped to x plus 2. That's where we are getting the word called mapping as well. F maps x to x plus 2. F maps x to x plus 2. These are the reading techniques, or the how we're gonna read these functions in as a English context or English statement. That's what here they have mentioned. So
Okay.
here for the function of x is the output value of the function f when the input value is x. So you know we normally already equalize this fx into y because y refers to always as output. Then this function of x value is actually the output value, that is y. So that's what here also they have mentioned. For example, when fx is equals to x plus 2, so the meaning of this fx means that is a function of x now. What will happen if we have f5? What do you think?
If I means we have to substitute 5 for the x value.
Yes. Instead of this x, wherever we have this value, I mean the x value, we have to equal this value of x as 5. So we have to replace all these x values with the term of with this term of 5. Thank you. Where are the other with the terms of y. That's what here we have. So that's also done. Then if I move further, that part also done. See, now if x is the output value of the function, for example, when we have this one, then what we can do, we have to substitute this value 5 instead of this x and get the output value. That's also done. Then let's talk about these type of ones. See, fx is equals to x squared. So for these kind of ones, we have the curve like this. This is a many-to-one function. As I already told you, this is a many-to-one function because for multiple input values in x, we have one unique y value. But so far still, the y value, the output value will not repeating or duplicating. It's a unique value. Because of that, for these type of ones also, we call them as a function. Haridha.
Okay.
Then a many-to-one function has one output value for each input value, but each output value can have more than one input value. Harini, because here we have two input values which has only one output value. That means for this one output value, we can have many multiple input value, whereby the vice versa will not work. Vice versa means for this kind of ones. See, y squared is equals to x වගේ equation එකක් ගත්තොත් y squared is equals to x වගේ equation එකක් ගත්තොත් if we take the square root of both sides, you can see if we take the square root of both sides, that means y is equals to actually
Root x.
plus or minus root x, right? No,
Yeah.
sorry. Again, actually, what will happen here? We can have like how I gonna define it. So let's assume like this, square root of x. So square root of the x. Anyway, there we have plus or minus killer. We can have like multiple values, no?
Yeah.
Then for this square root of x value actually, okay, we'll do like this. You know that -2 to -2, okay. So how I gonna say it? So for these kind of ones, then we have the multiple, again, we have for this single y value, we have multiple input values. Sorry, for this input value, we have multiple y values, which is not unique. So these type of equations are coming under, quadratic equations are coming under these ones. So actually, this is not a function.
Okay.
That's what here we have. Am I confusing you? මට සමහරක්
Uh,
put and output සමහරක් වෙලාවට පැටලෙනවා. So here for this anyway, this one will be again a basic thing is for this input we have multiple outputs. If so, this is what we called one to many, which is not a function. That's the summary. So then, if we have, we can see that the input value shown has two output values. This means that this relation is not a function. So the set of input values for a function is called a domain. Now we know three type of things, one to one, many to one, and one to many. But here, one to many is not a function. Other two, that means one to one and many to one, it's already function. Then we should know about two keywords. That is, one is for the domain, the other one is for the range. Domain means the set of input values. And for the range means the set of output values. Here we have the domain, which we call the set of input values. And here we have the range, that is what we call the set of output values. So the set of input values for a function is called the domain of the function. When defining a function, it is important to also specify its domain as well. The set of output values for a function is called the range or codomain. There's another name as well. So domain or domain means the set of input ones. Then the codomain means the set of output values. So for that output values, we already gave the name called range as well. Nang of the function. So here, for example, if I go through with these worked examples, this is what they gave. Function of x is 5 minus 2x. Then the input value is x values. Output value gives us from this function of x, which is y. So they have defined this x should be in between minus 4 to 5. And also it can be minus 4 and 5 as well. Equal mark also there.
Yeah.
Mhm. And also x is in real number scalar they have given. Now first part is write down the domain of the function. So the domain will be what? The set of
Be
input value.
yeah, between negative 5.
Yes, negative 4 to positive 5. That is there. Sketch the graph of the function of f. Anyway, this is a line, no? Straight line.
Yeah.
We can draw it as well. Write down the range of the function of f. Range means the codomain. Codomain means the output. The set of output values. So when it comes to set of output values, what would be the values?
So here they have taken the negative 4 and 5, and
Yes.
then yeah, then we have to substitute the values and get the final.
Right, we have to substitute these values and find out what would be the minimum value for y and what would be the maximum value for y. Then when we drew it, we already know. So here we have now the what we call the minimum point as, we can't say it as minimum point. So when it comes to 5, we are getting minus 5 as the y value. Here, when it minus 4, then we'll get in the y value as 13. So then the y values or the codomain will be from, we can define it as this fx should be in between minus 5 to 30. It can be those two values as well, because here we have the equal marks. When x is equals to minus 4, we are getting the y value as 13. These also can be equalized. That's how it is. So we can replace this fx value fx with y as well. So that is it. It's clear, right?
Yes.
Okay. Can you do the worked example 2.2?
Okay.
Yeah, just do the worked example 2.2. I think, yes, you can do the exercise at home actually. This one is easy. Just do the worked example 2.2.
Okay. Okay, teacher.
Okay, that is done. Okay, then if that is done, then we can move to the next part. So the total theory part is clear, right? Then this one
Yeah.
is work. Okay. Now we have the composite functions. For these composite functions, what will happen here? So let's assume like we have two functions. One is g, the function of g, that is what we call gx is equals to 3x. And the other function will be fx is equals to x minus 7. Now, what we call the composite function means, so most functions that we meet can be described as combinations of two or more functions. For example, the function, this function of x, 3x minus 7 is the function multiply by 3 and then subtract 7. It is a combination of the two functions g and f, where this one also. Now, let's assume we just wanted to combine these two. Then what we have to do, these two can be described as the function. First do function g, and then do function f. For example, let's assume we have to calculate fg. This can be written as f note g as well. So the meaning is, so function of x means actually it's a function of x. No, here
Yeah.
what will happen, that is not a function of x, that is a function of gx.
Yeah.
Function of gx. That means wherever we have x term, we have to replace that x term in gx. So that means for the function of x, we have x minus 7. Now for the function of gx, we have gx minus 7. So for this gx term, we can replace that gx with 3x.
3x.
Then the actual final composite function will be 3x minus 7. It's
Okay.
clear. That's what we call
Yeah.
FG. There are like three notations. One is FG, the other one is F note G, the other one is function of GX.
Okay.
What we call.
I remember this part in
Yeah, this
advance.
part also, yes. When one function is followed by another function, the resulting function is called a composite function. The total one, the final output will be, we call it as the composite functions. That's what we call. And remember, these two are not equal. I think I have already mentioned you these ones are function of gx is not equals to gfx. These two are not equal. Because here මේකේ තියෙන්නේ function එක ඇතුලේ තියෙන x වෙනුවට we are replacing gx. හැබැයි මේකේ තියෙන I mean the outer function will be g. එහෙනම් g එකේ ඇතුලේ තියෙන x වෙනුවට we have to replace function of x. These two are not equal. Is it clear?
Yeah.
Okay. Can you go through with this explore 2.1 what they are saying?
Okay, teacher.
Okay, that's also fine. Then, okay. For this, can you do the worked examples only?
Okay.
Without looking these ones, we'll do the worked examples and you can do the exercise at home.
Okay. So teacher, like within how many months can we finish the 4 books for maths?
So here for the PO1 now, so we are doing this entire, so this is for the P1, right? P1, the total, okay, wait.
Yeah.
This book, yeah, Pure Maths, no, Pure Maths total book, we have only 8 chapters, right? As I can remember.
Yes, on the 8 in the May probability one also on the 8 chapters.
Okay, so here if it's 18 one nang, so we can complete 18 ones means we can complete at the end of Jan, we can complete this entire book.
The pure maths,
Pure
right?
Maths and also the stat ones.
The
එතකොට
other two also like that.
Oh yes, other two also like that. Other two also, for example, හැබැයි මෙහෙමයි. So for the some units now, we might have to take like much time. We can't come
Yeah, yeah.
like this approximately. Anyway, so anyway, you are taking the exams at the end, right? For all these ones, you are taking the
Yes.
okay. So that means how many books, how many papers you are facing? I mean, how many books are there? Pure.
For maths, it's 4 books, 4 papers. So one's pure maths, probability, statistics, mechanics, and PO3. Uh,
Ah.
that's for maths. For further maths, also again 4. So pure maths, mechanics, probability and statistics, and
Ah, that's the case,
PO.
right? Okay. Then we'll try to okay, I'll try to complete these ones mid of Jan. Then mid of Jan now dates to right? For the mechanics and the that one also we'll try to complete 8 weeks now. Pure maths part is but for the mechanics, there are mechanics is kind of applied one. Maybe we have to. So you asked from me what would be the average time period, like per book?
Yeah.
I would say
No,
like
no.
per,
Like when we finish the whole maths part, I mean, there's no rush. I just
yeah.
want to.
So I can complete the whole maths part by April, March, April, yeah. So you
Yeah.
are taking
Okay.
at the end, right? November, right?
Yeah. Yeah. 2026 November.
2026 November.
Yeah.
2026 November. Then, then we can like first we can complete these two.
Yeah.
Anyway,
Yeah.
you don't have like term test and those ones, no? So
No.
okay, then what we can do, we can anyway complete by I can complete at the end of Jan or mid-March වෙනකොට these two. Then the other two also, again, it will take another 2.5 months. 2.5 months to 3, I guess, because for the mechanics now, we have to like do it carefully because that is not like pure. No? Again, pure
Yeah.
memory, but it's our application based one.
Yeah. Yeah.
So got for the maths one, anyway, we can complete like that. They got per subject approximately 10 weeks. I would say
Yes.
10 weeks means 2.5 months again.
Yeah. Yeah.
These two now I'll be submitting it in hey money. I thought that you're taking it the total exams like that කියලා. ඒ නම් හිතේ මොකක්ද?
So teacher, when did you assume I'm going to take exams?
Sorry?
Like when did you assume I'm going to take exams? Like
No, I thought you're doing at the end of the Jan කියලා. කියන්නේ අවුරුද්දෙන් දෙකම කරනවා කියලා.
ah
That's what again. I mean, the end of 2025 කියලා. Now we are taking it on 2026 mid ne. Again, I think it's May June exam, right? You are taking for the October November one.
that I'll kind of decide when I get closer to exams, depending on
I
how
got
the subjects are covered. But I'm aiming for the May June one.
May June one, yeah.
That I'll decide like
Okay. Then
depending
there
on
are
how the
also
subject.
for the university applications also there's a benefit now if you do it like මේ ජූන් වන්නෝ දැන් අර we can first one then you can like go with the same year. I mean same year, but if not, if you do it with the October November one, you have to wait for the next batch. මම කියන්නේ එහෙම මොනවා හරි කරනවා නම් there's a benefit
Uh-huh.
on that one as well. අපරාධින ඉතින් වෙලාව.
Okay, I didn't know about that.
Okay,
Yeah,
so
so
there are
any,
also there's a
yeah,
yeah there's a because anyway to get your results they are taking like I think 2 to 3 months මට මතක විදිහට. So there if it's like that, if you do it on ඒ කියන්නේ on no before the May June one, ඒ කියන්නේ mid එකේ කරනවා නම් then you can apply, there's no any delays, you can apply it from that same year itself කොහොම හරි. එතකොට right after next batch you can enter for the universities, but if you do it for the October November now you have to wait like පොඩි 3 to 4 months හරි මොකක් හරි එහෙම පොඩි gap එකක් තියෙනවා, you have to wait.
okay, teacher. So I'm planning on taking the exams on like
Yeah,
May, June.
that's it.
But yeah. So anyway, teacher, there's no rush. We can slowly do it.
Yeah, that's the case. Okay, okay. Actually, I was thinking like you are doing that taking all the exams by again within 2025 කියලා තමයි මං හිතන් හිටියේ. So
No, 2026.
2026. Okay.
Okay, teacher, done.
Okay, those ones are done. Then, so worked example 2.3, 2.4 also done, right?
Yeah, I did 2.5 and 2.6.
Okay, 2.5 as well as 2.6 also you can do. So that is there. Then we have exercise. What do we have? Okay. Can you do the question number 19 as well? The practice ones,
Okay.
the red color.
Okay, teacher.
Okay, done, right? Then we have the entire question is fine, right?
Yeah, yeah.
Okay. Now we have the inverse functions. So for this inverse functions, inverse also I think we already have done these ones.
Yeah.
Yeah, so for the inverse of a function, that is fx is a function that undoes what fx has done. So here we write the inverse of the function fx as f inverse x. So now what will happen here? The function of x means fx, and for the inverse function, we denote it as f inverse x. So the relationship in between these two key point is actually the domain of the function will be the range of the inverse function. The
Yeah.
range of the function, original function, will be the domain of the inverse function. It's a vice versa thing. Then
Yeah.
it's important to remember that not every function has an inverse as well. There are a few conditions which we need to satisfy to have a inverse function for a function. So an inverse function f inverse x exists. What are the conditions they need to satisfy? If and only if the function fx is a one-to-one mapping only. If not, for those ones, there's no any inverse function for other functions. It should be a one-to-one mapping. It
So
should
like for linear function.
be linear ones, yes. No, it we can't say it's like a linear one, Makila, because see, something like this also happens now.
Ah, yeah, yeah.
So we can't say like it's always a linear one. Something like this also can be, because this is also a unique one. So
Yes.
for these type of ones also it can be. Now what will happen for here? So you should already know how to find the inverse function of some simple one-to-one mappings. We want to find the function f inverse x. So if we write y is equals to f inverse x, then function of y. Okay. So how it calculate? Let's assume we have to calculate y is equals to function of 3x minus 1. So that means y is equals to 3x minus 1. Then our next step would be we can
Wait.
make x as a subject actually. That would be the best method. We can make this x as the subject, that is then y plus 1 is equals to 3x. So actually the x is equals to y plus 1 divided by 3 now.
Yeah.
Then what we can do, we can interchange the variables. We can interchange x and y. So here it becomes y is equals to x plus 1 over 3, okay? And this y means not exactly the output y, that is f inverse x. That's the inverse function actually. Then for the fx function, what we have 3x minus 1, we have the inverse function x plus 1 over 3. So if f and f inverse are the same function, let's assume, over again. So here what we have is fx is equals to 3x minus 1, these ones. If the function and the inverse function both are same, I mean, both, if we have the same function for both, then we call them as a self-inverse function. Inverse so because of that, we
Yeah.
call them as self-inverse function. For example, if we consider the function of x as 1 over x, for x is not equals to 0, then we have function of inverse x is 1 over x. Both are same anyway. Then we call those type of ones as a self-inverse function. It's clear, right, the theory part?
Yeah, yeah.
Okay. Then okay. Can you go through with the Explore 2.2 as well? Answer these. What type of mapping in this function? That means we should state whether it's a one-to-one or one to many or many to one. So if this is a function anyway, we have to select from those two and then
This is
coordinate.
a many to one.
This is a, yes, many to one. Yes, this is a many to one. Then what are the coordinates of the vertex of the parabola? When it comes to what are the coordinates of the vertex?
Here,
Yeah.
2, 1. 2.
Yes, vertex means anyway the turning point again. Then it would
Yeah.
be when x when this bracket equals to 0, that means x is equals to 2. එතකොට you can calculate that one as 2, 1 as well. Then what is the domain of the function?
X is in real.
Real numbers. That means actually the negative infinity to positive infinity. You can write like that one as well, or else all the real numbers set. Both the notations are, I just saying these ones too, so that you can easily familiarize with these ones. So
Yeah.
the complete real number set, you can either notate it with the set theories, negative infinity to positive infinity here as well. Then what is the domain of the function that is done? What is the range of the function?
Um,
So range means the set of output values, no? Here, the
yeah.
minimum value will be here. We have 1. And
Yes.
also from here to up, we will be
Yes.
getting those what we call the
Output values.
values. Here, we can mention it as 1 to positive infinity. Okay, 1 to positive infinity can.
Or greater than equal to 1.
Yes, yes. So greater than equals to 1 also fine. And also we need to check whether 1 is a possible value. Oh, ne? 1 is also a possible value. Yes, because it touches, no? Then
Yeah.
say like this. So
Okay.
all the y value should be greater than or equals to 1. All the positive values. That's also fine. Does this function have an inverse function?
No.
No. If f has an inverse, since if f has no inverse, what is it? If not, then how could you change the domain of f so that the function does have an inverse? What do you think? To get an inverse function, how we gonna change the domain of this one?
I'm not sure. How do I do
That means actually, then here we have the many to one. No? That means many to
that?
one
Yeah.
should convert it into 1 to 1. For example, if we have the graph like this, see, if we draw only this part, then it would be a 1 to 1, right?
Yes.
Then the other way, from if I consider only this left-hand side part as well, then again it would be 1 to 1.
Yeah.
Then how we gonna define the respective domains for these two? What do you think? Domains means the input values. Set of input values. So one method is now the midpoint or the vertex is where that is in tune.
Yeah.
We can consider it from 2 to positive infinity. Okay, 2 to positive infinity. Or else we can say minus infinity to plus 2.
Hmm.
See?
That means like x is greater than equal to 2 or x is less than or equal to 2.
Yes, yes, yes. එතකොට ඒ වගේ we need to consider it into two graphs. ඒ කියන්නේ දෙකකට තමයි consider කරන්න වෙන්නේ because we can't merge it together and say then again what will happen? It will become a many to one one. ඒ කියන්නේ many to one function.
Yeah.
Because of that we only thing what we can consider is we can consider this branch or either this branch at once. එතකොට ඕක තමයි explain කරන්න වෙන්නේ. So you can draw this one and then say to get this kind of a graph now, we should consider the domain like this 2 to infinity. For this type of a graph now, then we should restrict the domain as negative infinity to 2.
Okay.
That's what we have. Okay. Can you do the worked example 2.7 and 2.8?
Okay.
Yes.
Okay, teacher.
Okay, that is done. Then the 2.7 done. So 2.8.
Done.
Okay, 2.8 also done. Then you can do this 2C. Shall we do the 15th and the 16th questions only?
Okay. Okay, teacher.
Okay, that's also done. Then, okay. So that's also done. Then what do we have? Hmm. Okay, this is done. Then we have okay. No questions, right? That's also clear.
Yeah.
Okay. So here for the Cambridge Internet, okay. So the graph of a function and its inverse. So now how it works. So for the graph of a function and its inverse, no, here we have consider the function defined by fx is equals to 2x plus 1. For x is in real numbers, there we have minus 4 to 2. Okay, so, okay, now let's assume we have a function to draw, that is function of x is equals to 2x plus 1. Then 2x plus 1 for x is in real numbers. That means, so x is in real numbers and they have given the domain as well from minus 4 to 2 here. What will happen here when the x value is minus 4, the y value will be minus 7. When x value is 2, y value is 5. That can be found or get by using the values on it. Values on it means by substituting the values for respective values for x, we can have those values. Then that is done. So the domain of f is minus 4 to 2 and the range is minus 7 to 5. Now, if we consider the inverse, we can calculate the inverse and we will be getting the inverse function as x minus 1 over 2. And the domain of the original function will be the range of the inverse one. The range of the domain, range of the original one will be the domain of the inverse one, the vice versa case.
Yeah.
So here the domain of f inverse is the same as the range of f, hence the domain of f inverse will be this. And the range of f inverse is the same as the domain of f. That means hence the range of f inverse is this. That is it. Then we have the representation of f and f inverse on the same graph can be seen in the diagram opposite. See, by looking at here, you can see the original function will be what? The original function is in what we call 2x plus 1. No? Then the original function will be like this, 2x plus 1. Then here we have the x minus 1 over 2 function. That is the inverse one. This one is the inverse one. This one is the original one. So what will happen here? See the mirror line. That is actually the mirror line is y is equals to x. These two are like symmetric ones.
Yeah. Reflection.
Reflection, yes, from the mirror line itself. So the representation of f and f inverse on the same graph can be seen in the diagram opposite. It is important to note that the graph of f and f inverse are reflections of each other in the line which is y is equals to x. So this is true for each one-to-one function and its inverse functions as well. This is only true for one-to-one functions. So the key point will be the graph of f and f inverse are reflections of each other in the line y is equals to x, and this is because f inverse x, that means f inverse x is equals to x and f inverse fx is equals, both are equals to x. When a function f is self-inverse, එයාගේම inverse එක එයාම නම්, then the graph of f will be symmetrical about the line what we call y is equals to x. Is it clear for you?
Yes.
Okay. Let's go through with the 2.9, I mean the worked example. So here, Okay, just go through with the go through means actually do the worked example.
Okay, teacher.
Okay, that's also it's clear, right? 2
Yeah,
point. Okay, how it works and also 2.10.
that I didn't do it.
Okay. Just
Okay, teacher.
Okay, that's also done. Then for the Explore 2.3, here we have, okay, Ali states the diagrams show the functions f and g together with their inverse function f inverse and g inverse. So, is Ali correct? Explain your answer. What do you think?
He is correct, right? I mean, they are
Yeah,
reflections.
yes, because actually it would be okay, yes. Anyway, it's yes. A node. So here for these kind of ones, this is not an one other
A one to one.
yes.
Yeah, yeah.
So then this is a many to one function, no? Then many to
Yeah.
one function means then it can't be have inverse as well. එතකොට ඒක හරි නෑ actually. For the first one නම් it won't. And for the second one also ඉතින් මෙතන ඉඳන් මෙතනටත් it won't correct නේ because again we have like multiple values, no? So then
Yes.
that's also not correct, yes. Okay. Do the fifth question, the last practice question. How many topics are there remaining? Five, six. Oh, this one's not example. Ah, that's it. That means the final exercise would be 2H, right? 2H means 2.14 when account we have. Do the fifth one as well. Some units are lengthier and actually it will take some time,
Yeah.
more than 1 day. These books are really good. I mean, for the Edexcel and Cambridge one, but for the local A levels, we don't have books. No, I already told it right previously as well. See,
Yeah.
if someone like would like to do like self studies and do, then actually it's good. So in
So
our
if there aren't books in the local syllabus, how are students studying?
No, then we have to anyway go to school and then we have to note down. I mean, so whatever they are given, then we have to do it. There are some authors who have right who have
Published.
published books related to those units and chapters, and the tuition masters are also at a mass. Me, good massively Karan I get there are like tunes and those ones. Other than that, we don't have anyway. We didn't actually. I did it in 2012 no. So then at that time, no such thing, no such book to refer. So whatever we created, we referred. අපි ඔය notes වල ලියාගන්න ඒවා එවෙන් තමයි අපි කරේ. But now I guess අර NIE, have you heard that the national මොකක්ද NIE කියලා එකක් තියෙනවානේ. Then from that one, maybe sometimes they have from the Department of Education department එකෙන් වගේ I think now they are developing some books and the ගොඩක් self study කරන අය ඉන්න නිසා I think
Yeah.
they topic wise they are making those ones.
Okay. So teacher, here in part A, what does a self-inverse mean?
Self-inverse means actually if we have a function like fx, Then once we calculate the inverse of it, the same fx function should come as the f inverse as well. Both should be equals.
Um,
Function and the inverse function. Both should be same. එහෙම නම් තමයි we can call it as self inverse.
okay. Teacher, I did the fifth question part A. Part B, I'm connected.
Okay.
Hello, teacher. Hello, teacher.
You were saying that you are doing the part B, right? Oh, did you ask from me help or something?
Yes.
Okay. I thought that okay. So here for the gx is equals to ax plus b over cx plus d, and for x is in real number set, then x is not equal to c over d. Sorry, d over c. Why they have mentioned like that? Because if it's equals to that, then the gx function goes undefined, no, not defined.
Yeah.
Denominator becomes 0. Then x is in real numbers, this one, where a, b, c, and d are constants. Find the condition for this function to be self, no, to be self-inverse none. Then what we have to do, same as the previous one. So here, gx.
Here they're asking about the condition. So.
Yeah, condition means anyway, so you should have an expression in between A, B, C, and D. All these ones එක මොන එකක් හරි ඇති මේ condition එකක්. That's why they are saying like that. Gx is equals to ax plus b should divided by cx plus d. Then actually that means y is equals to this one. Then if I make x as the subject, then that means ax plus b is equals to y ycx plus yd, and then what will happen if I take this to here, x is equals to yd minus b divided by then we have make a then a minus yc. X is equals to yd minus b divided by this one. Then what I do, I just replace this x and y. So here that means this becomes f inverse, not f. G inverse x is equals to xd minus b over a minus xc. That's what we have. So then what will happen? This one, okay, this one should equals to this function. I mean ax plus b over cx plus d should equals to xd minus b over a minus cx, a minus xc. Because to become a self-inverse function, that means the fx and the f inverse x both should be same. That means these two should be same.
Yeah.
Now what will happen?
Shall we cross multiply and solve?
Yes, that one also done. Or else what we can do, rather than doing cross multiplication and that thing, we can do what? So the thing is, so these two, so here we have ax, right? I think here we have ax. So then here also we have ax terms. If we compare the, if we compare the, if we compare the x terms on the denominator, then here we have ax and here also we have ax, and here we have b, here we have minus b. And then මෙතන තියනවා cx plus d. Okay, this one is there. Okay, what they are saying is this. Okay, that's what they are saying. A, B, C, D, all these ones are constants. And then find the condition for the self-inverse, right? If they ask us to find the condition for the self-inverse, that means, what was it? Let me check. So for the conditions means, once you equate these ones, numerator equally and the denominator separately, in order to achieve these conditions. Both should equals to x actually. Okay, wait. What was there in the previous note? So this part is done. Now we had this one, right? Symmetrical about the y-axis. See, f inverse, so the function is self-inverse. The graph y is equals to fx is symmetrical about the line y is equals to x. There I saw a condition. It is important to note that the graphs of f and f inverse are reflections of each other in the line y is equals to x. This is true for each one-to-one function and its Inverse functions, okay, one-to-one functions and its inverse functions. Now, what here they have mentioned? Find the condition for this function to be self-inverse. If it's to be self-inversed, if it's to be self-inversed, the exact relationships among A, B, C, D depend on solving these equations, resulting to general case. Then Gx means this one's are derived as specific relationships between the A, B, C, D. So that is actually okay. Composite is equals to x කියලා එකක් තිබ්බ නේද? Let me check. So the theory composite value also should equals to 1 කියලා එකක් තිබ්බ. X if inverse x is there. So the self inverse function is there. Fits okay, that is there. And then we have on the same graph it has okay, that's it, right? Y is equals to x. On the keywords there's nothing much. And then directly they have one, okay. Then find the condition for this function. Find the condition for this function. Then what we can do is according to the given question. Anyway, we should have it like find the condition for this function to be self-inverse. No? If it's to be self-inverse, then that means these two should equals and these two should mirror or the reflections. These two has to be reflections either from again y is equals to x කියලා කියන එකෙන් these ones should be there. Okay, mirrored. එතකොට that one also done, but I have a question. Okay, that means what you can do, you can equate everything and find the value for x, right? So then the x becomes, x will be, so,
In the answers they have given d is equal to negative y. That's the condition that they've given.
b is equals to?
D is equal to negative y.
D is equals to negative a. Only that one?
Yeah, that's the answer that they've given.
Okay, so that means what about the denominator? So here, Cx is there. Okay. We'll do like this. So we need to consider this as, no, but that one also can't be right because here we have, anyway, we have received Ax plus B over Cx plus D is equals to Ax.
That is D, teacher. That's
D.
not A.
Okay. Dx minus b divided by a minus xc, right? Then what we can do, හැබැයි මෙතන x term is in positive, this x term is negative. Okay, we'll do like this. We'll take we'll take negative from both denominator and the numerator. And then එතකොට මෙතන එන්නේ b minus dx divided by b minus dx should divided by cx minus a. Then hello. Okay. So here what will happen? Then what will happen? Now these two are the cases. No. Then by looking at this, you can see. So for the right and then the final one would be on ax plus b over cx plus d should equals to b minus dx over cx minus a. So for the denominator, d should equals to minus a. That's true. එතකොට There's a one condition there. එතකොට for the denominators will equal. What about the numerators? Two numerators. Okay. So here also right? See, by looking at this, what will happen? Only that is the condition. See, ax plus b over cx plus d. Then for the right side, we have b minus dx over cx minus a. So to denominators, to make those denominators equal, here also we have cx, here also we have cx, then d should equals to minus a, no? That is,
Yeah.
then the denominators equal. What about the numerators? Numerators, here we have b, here also we have b. Again, we have ax, which is positive here, and here we have minus dx. When we compare the x terms, again, apita hamba wenne a is equals to minus d. See, only one condition needs to satisfy. Is it clear for you? No.
So then, but A equals to negative D and D equals to negative A, it isn't the same.
So those are same. A equals to
Ah,
minus D.
yeah,
And if we write it like D is equals to minus A, again, this one, if we
yeah.
yeah, multiplied both sides by minus, again, then we'll receive A is equals to minus D. See, only that
Yeah,
is
yeah.
the condition we need to satisfy, Shah. That's a good question.
Okay.
So anyway, I'll erase. Do you want me to keep it? Anyway, what you have to do is, okay, sorry. Anyway, what you have to do is first starting from this, first start from here, and then just find out the G inverse X. That means the inverse function, inverse of that function. Once you find out that, try to equalize those two.
Okay. Okay, teacher.
Okay, that is done. Then what do we have? Hmm. That is done. Then we have okay, transformation functions. First, let me. Then for the transformations function, okay, what they are mentioning before that. Ah, now what we are going to do, so now we know what are the functions and inverse functions to select, to check whether the given relation is a function or not. All these ones we already knew. Now what we have to do, so now what we have to do actually, transformations of a function. Now here, O level, you met various transformations that can be applied to two-dimensional shapes. These included translations, reflections, rotations, and the enlargements. This is kind of a new part.
Yeah.
Next section, you will learn how translations, reflections, and stretchers, and also how we're going to combine all these ones together and make a complete transformation of a function killer, we will be discussing. So here for this one, explore 2.4. Okay. So explore 2.4. Now what will happen? Use graphing software to draw the graph of this one. Let me share my whole screen. Then if I show you how we're going to do this, I have already shared my whole screen, and then I'll search for an online graphing tool. Graphing tool. Okay, then I'll go with the Desmos or the GeoGebra. I think I'm very frequently using the Desmos one. Yes. So this is what I'm frequently using. Now what they are saying, graphing software to draw the graphs of these three. No, then I'll
Yeah.
draw these ones. Y is equals to x squared. Y is equals to x squared. Okay, I'll keep it like this. This is like this. Otherwise, I have to always go back and check. Okay, this is like this. Okay, once I did. Okay, now what we have to do is to open this one. Okay, I'll first type these ones. Y is equals to x squared. Then y is equals to x squared. That is the first one. The second option is y is equals to x squared plus 2. X squared plus 2. X squared plus 2. That's also we already drew. And the next one is y is equals to, I'll copy the same thing and I'll keep it as it is. And then I'll put it as minus 3. Those are the three graphs. Okay, anyway, it will be looks like this. Now what will happen? What they're saying is, okay, I'll try to minimize this. Okay, now using graphing software to draw the graphs of y is equals to x squared, y is equals to x squared plus 2, and also y is equals to x squared minus 3. Now what they are saying, discuss your observations with your classmates and explain. The second and the third graphs would be, okay, something like this. Then here what they are saying,
So we are changing the y-intercept, right? Like, yeah.
yes, so here, discuss your observations with your classmates and explain how the second and the third graphs could be obtained from the first one. That one we already know, no? Because can you okay, I couldn't remember. So here, if it's y is equals to x squared, now we have this one. See, They have done y is equals to x squared plus 2. If it's x squared plus 2, that means all the y values have been moved up by 2. දෙකකින් වැඩි වෙලා හැම එකම, right? The minimum
Yeah,
also it will be now earlier the minimum y value was 0, but now it's 2.
the vertical trans.
Yes. Then for the third one, for the last one, now for y is equals to x squared minus 3, it has පල්ලෙහාට ගිහිල්ලා තියෙනවා. It has been gone down in 3 units.
Yeah.
See, the y values has been changed. එතකොට ඒක තමයි, that would be the discussion. So now for the B, repeat part A using the graphs. Then they have asked us to repeat part A using the graphs for these ones as well. Now what we have to do? So if I draw these ones, so earlier these ones was there, I have to go to repeat part A using graphs. Okay. Then they ask us to, so this one is done. Then I'll just move it as, then, okay, we can use the same thing. We can use the same thing, but what will happen here for the power?
Power becomes half.
Power becomes half. Yes, that's the easiest way to change this. That's what I also thought. This one, and also here for this one, and also here for this one. Okay, this value would be 1. This value would be -2. That's what here we have. So now, if you check for this, see, this would be something like this. අර නිකම් මෙහෙම අරගෙන මෙහෙම යනවා. Then again, what will happen? The same thing. If we draw y is equals to square root x, to draw y is equals to square root x plus 1, we need to move up. We need to move up we need to move up the graph from 1 unit. Then here if we have square root of x minus 2 now, then we need to take it down. අපිට පල්ලෙහාට දෙකක් යවන්න වෙනවා. That is it. Is it clear?
Yes.
Okay. Then using the same thing, repeat part A using these graphs as well. Can you generalize your results? If we generalize our results, then what would be our condition, not the condition? What is the statement there we have?
So we are changing the vertical like translation.
Yes, actually, we are moving the graphs. We are moving the graphs along with which axis?
Y-axis.
Y-axis, yes. Then that's what they have mentioned. So we are moving the graph along with the y-axis. If it's +2 now, we need to like move up from 2 units, the entire graph. If it's a -3 now, then it would be we need to take it down. We need to move further down in 3 units. That's what we have. It's clear, right?
Yes.
Okay, then the first part is done. Then we have the next one. Next one is actually there we have y is equals to x squared. Okay, I'll close these ones, that's fine. The next one would be y is equals to x squared. Then the next one is y is equals to x plus. I'll draw these two here. Then here we have y is equals to x plus 2. X plus 2. And it should be, the bracket I'll put like this. And I thought x plus 2 squared. And the next one would be, if I copy this down and take it down like this, then I'll put it as -5. -5, okay. Now what do we have? Here we have y is equals to x squared. So, see, now this one is the black color one, y is equals to
X.
yes. So then here what do we have? For this for this black color one, if it's x plus 2 is squared now, where they have moved, where it has moved. What do you think?
It has moved along the x-axis.
Along the x-axis for the left-hand side or right-hand side?
Left
Yes. If it's, see,
hand.
if it's x plus 2 now, it has been moved to the left.
Yeah.
The entire graph has been moved to left by 2 units. If it's x minus 5, okay, එහෙනම් it has been moved to right side.
Right.
Yeah, right side by 5 units.
So how does the x plus 2 moves to the left hand side? Because 2 is also positive.
Okay, that's how it. So here මොකද්ද මේ sorry හිරු කියන්නකෝ මේ මෙතන department එකේ කෙනෙක් කියලා ප්‍රශ්නයක් ඇහුවා. Let me කියන්න මම අන්තිම කෑල්ල අහන් හිටියේ නෑ.
So teacher, how does x minus x plus 2 squared move to the left hand side? Because here 2 is also positive.
X plus 2 gets squared, you ask him why it moves to left hand side, right?
Yeah, because according to the graph, now it is like negative. So
Yes.
how does it happen?
So why? The reason is, see, earlier means the first graph is y is equals to x squared, no? Then
Yeah.
the second graph is x plus 2 gets squared. Now, see here we have x terms only. Here we have x term only. To make this bracket as x term, hurry, to make this bracket as x term, what we have to do? We have to remove
Ah,
this
yeah, yeah.
one.
Yeah.
එතකොට මේක වෙන්න ඕනේ x plus 2 නෙමෙයි actually this should,
Minus.
yeah, we have to like add කරලා තියෙන එක we need to minus it, right? Then
Yeah.
we need to take it to the left side. හැබැයි දැන්
Okay.
third one, if we have like y is equals to x minus 3 k squared, then to make it this x squared, make I x squared කරන්න නම් what will happen? Again, we need to add another 3 units. මොකද
Yes.
දෙකක් add කරොත් විතරයි then it will become x squared. එහෙනම් we need to take it to the right side. So
Okay.
that's how I normally, I can mama practice කරන් තියෙන්නේ that according to that method.
Okay.
Okay. So then, okay, I think that is clear no now. That is
Yes.
clear means, so anyway, if it's x plus 2 gets squared now, then the graph will be moved to the left along the x-axis. For the x minus 3 gets squared now, graph will be moved to from left to right in 3 units. Here along the x-axis. That's what here they have. So that transition also you can do. Then the next one we have okay, x cube one. Okay, the same thing, same set of thing. There we have x cube one. So no, okay. Before that we have the x squared one as well. X squared, and the next one is the minus. Okay, this one now you should be able to tell me. What do you think? What will happen if it's x squared and minus x squared now? What do you think?
Minus. So yeah, it should be like the reflection.
Reflection. Yes, it would be the reflection. From what?
X-axis.
From the x-axis. From the x-axis. Yes, that's true. So that's also correct. Then if it's x cube and minus x cube, that's also the same thing. It will be
Yeah.
like this. And yes, that's also done. Now what will happen? Use graphing software to draw these ones. Okay. Now 5 plus x and 5 minus x. What do you think what will happen there? 5
5.
plus, sorry, 5 plus x. 5 plus x. And then we have 5 minus x. What do you think what will happen? Only
Again,
difference.
Yeah,
Yes, only difference is the gradient has become negative.
negative.
Right?
Yeah.
The gradient has become negative means these ones will look like this. See, that's how it is. So 5 minus x. Okay, that is there. Then you should, so I'm not graphing the B and C because the same thing, no? So
Yeah.
now here what we have it has been, we have a positive gradient and for the other one we have a negative gradient. So for the last one, then we have, how we gonna draw the powers? How we gonna draw the powers there? First one is to x squared. First one is 2x squared, the other one is 2x squared. 2x squared, and the other one is the 2. Okay. First, tell me these two. If we compare the y is equals to x squared and y is equals to 2x squared, what we have?
So it's like 2 times bigger, like, how to say. So here, like the gradient, not the gradient.
Yes. So then what will happen here?
It has like expanded, like the graph has expanded.
No. So if it's 2x squared now expanded නෙවෙයි. It has been narrowed down. Because the y value is getting multiplied by 2. දැන් මෙතන black color එකෙන් we have drawn the y is equals to x squared.
Yeah, no.
Yeah,
Okay,
but
okay. I thought the green was x square.
no, no, no. For the green one was the 2x squared one. That means actually, okay, you can't see the graph. No? So here for the green color one is y is equals to 2x squared means then කලින් එකේ we have received y value for x squared. That means the y value has been doubled up. The y value has been
Yeah.
doubled up means y value has been doubled up means actually what? That means it's getting narrowed, again, narrow down. It's getting much closer along the y-axis. Hari,
Yeah.
ඒක තමයි එතන වෙන්නේ. So, what do you think? What will happen for the maker? If I make it as a complete power, then within bracket, then we have, let's assume we have like this. See, then what will happen? Actually, the 2x ke complete squared means we have what? 2x ke complete squared means we have 4x squared.
Yes.
4x
It
squared.
has further narrowed.
Okay, that means 4x squared. Yes. Then, which means if it's 4x squared means so here what will happen if it's 4x squared, then actually it has been narrowing down more, right? තවත් ලං වෙලා.
Yeah.
Then the y value is, so if we compare this one and this one, that means here, from here to here, y value has been multiplied by 4. එතකොට එහෙම වෙනවා කියලා කියන්නේ it has been narrowing down further. That is the green color, purple color one.
Okay.
Okay, clear for you the transformations, the simple transformations,
Yeah.
whatever we have done so far. Okay,
Yeah.
we do like this. Anyway, we'll stop from here for today. So I'll be starting again from this transitioning part next week also because I feel like it's a new thing because this one you need to do it for the sine cos trigonometry ones as well in future. So because of
Okay.
that, we'll again start from here next day and then continue from next day.
Okay.
So up until this, up until this one, you can complete your all the remaining exercise and the homeworks and explore ones as well. Okay.
Okay. Okay.
Okay, then thank you so much. See you in the evening as well. Let me know at what time we were discussed. 6:30, right?
6:30, yes, teacher.
Okay, okay. So okay, I'll complete that one as well. Thank you. Then see you in.
Okay, see you, teacher. Bye.
Bye.